Thank you, Benetton. Back to being friends. 1K diamond. Baju dangerous. Baju tadi memang cantik, tapi baju ni lagi dangerous. Nak cantik tak mau dangerous. Oh ya. Biasanya orang nak yang dangerous. Saya sekarang bawa turun dan curl ke dalam. Macam tadi ke? Back to I got my red dress on tonight. Berapa banyak boleh buka butang tu? 1 butang, 1K diamond. Sini ada 1, 2, 3, 4, 5 butang. 5 butang. Saya boleh buka semua. Boleh tapi beberapa. 5 saat. Tapi dari belakang, kat belakang. Tak boleh kat depan. So macam mana? Comellah pakai cermin mata. Thank you, Syawal. How are you? Thank you. Kalau ternampak sikit kira rezeki ke? Kira, iyalah. Kira rezeki.
Okay, so steel has a pretty nice property. It's much better mechanical property compared to the concrete. Then why don't use the just steel for structure? Because
Bukan macam cikgu.
okay, so steel
Macam cikgu tak?
concrete, and but steel has a 250 to 500 megapascal of the strength, even compressive tensile equal. Okay. So even tensile strength is 250, compression is 250, almost.
Thank you,
Tensile and compression behavior
Kelvin.
is similar.
Okay,
And
one button off.
stiffness, elastic modulus is also very high, usually 200 gigapascal. And concrete, you remember that it has around 25 to 40 gigapascal.
Dari kelas tak, aduh tak ada.
9 times higher than concrete. And if you remember the concrete strength, maybe 30, 40 megapascal, so still is much higher than that. And
weh, IV tu dah 70.
it's not like concrete. Still has
Eh,
a
70, 700. Thank you, Kelvin. Okay, kita spin. Spin.
And durability, always corrosion is the big
Untuk
issue in steel
Kelvin.
reinforcement. So we have to care about the corrosion issue. You might need a particular coating or particular treatment to prevent the corrosion. Okay. And also to connect it, you need a particular special tools to connect the two different steel components, such a thing, welding and such a things, right? One of the concrete benefit is that actually we can make the foam, we can pour or the liquid, and then we can make the different shapes of concrete, but still require particular fabrication. So this is how the steel behave in under the load, stress strain curve. I believe that you already have a pretty good idea about this curve. So initially it showed a linear elastic behavior, okay, up to the here, and we call it this is
Okay. Tu kau kena nampak bintang. Oi, jangan.
relieving stress
Bahaya.
of the steel. So once you reach
Cik Tumblr.
here, this is a linear elastic, so you exactly follow the linear elastic behavior. However, if you
Okay.
reach the field point,
Thank you,
then
Kelvin.
now
Kita
you
speed
can
into
stretch
Kelvin
the
lagi.
steel without increasing the stress. So this is yielding. So from here to here, you can see that there is some yielding without increasing your stress, just you have a strain increase. And then if you keep going, if you keep increasing strain, then now you can see another strain hardening behavior. Now stress increase a little bit more. And then finally we have some maximum ultimate strength of the steel. And then you have some necking behavior happen, which means that your steel surface area decrease because of necking. And then finally you got a rupture. This is your overall behavior steel reinforcement. And we need to keep in mind that in our designing purpose, we don't consider all this stress strain curve. Only we are interested in this area. Okay? So we intentionally designed the steel behave in this linear elastic and yielding ranges. Okay? So whenever we go to the certain level of the yielding and your concrete component will fails, so you'll have a collapse of the structure. So when steel doesn't in the exact region of your concrete behavior, they'll never go to this hardening behavior. Always elastic and maybe go to the yielding behavior. Then we can understand that in designing purpose, the important thing is what's the yielding stress and what is your elastic modulus of the steel. Then it's the yielding strain. Okay, so these two values may be important in the designing, and we will see. Okay, and still, it usually wrote we are in the steel bar, which is very long, several meters or even 10 meters or 5 meters, depending on your structure design. But most of the steel, you have this kind of a deformed shape. It has some surface is not smooth. It has a lot of the roughness, and intentionally we give this kind of a deformed shape. Why? Because to make the steel behave together with the concrete. Okay? So one of the very important assumption of the steel reinforced concrete design is the perfect bonding. We design everything assuming that this is bond perfectly. So concrete at the level of the steel would behave exactly the same as the steel because of this perfect bonding. To give a perfect bonding, of course, in reality, there's no perfect bonding, but we need to try as much as possible to give a perfect bonding, close to perfect bonding, giving this kind of the different roughness of surface, increase your this bonding behavior of the steel. If you just have a very smooth shape, you can easily understand. Slipping or collision. Okay, so that's why we have a deformed river. Okay, and then let's a little bit talk about what type of the different steels are used in concrete design. Majority of the elastic modulus, it's almost 200 gigapascal. So unless you have a specific value in the question, you can simply assume the 200 gigapascal of the ES. If you cannot find the ES value in the question, you can simply assume 200 gigapascal. But if you have a given different value, of course, you have to rely on given specific value. However, 200 gigapascal is commonly used value for steel elastic modulus. And
Okay, kita speed untuk Benetton.
in terms of the yield stress, it changes. It depends on the what scale you are using. 200 megapascal, 400 megapascal, or you have a 500. Even recently, we also add more higher one, 650 megapascal like that. So you have to read your question well, or you have to read your specification well, what type of steel you are using. Okay? So about the ultimate tensile strength, we don't have that information. Ultimate tensile strength means that this value, we don't have it. Why? We don't need it because our designing process never reached that value. Okay? And
Thank you, Nujum.
ductility. So you can read this bullet point. And ductility, we have a different ductility, non-ductile and normal ductile and high ductile. Of course, we mostly focus on this normal ductile behavior, which usually have a epsilon SU is.
Thank you, Nagis. Wah, Kelvin. Kelvin ah. Aduh. Okay. Satu butang. Satu key. Tapi tak boleh lama-lama yang butang bawah ni. Tapi kalau orang bagi lagi 3 key, kita buat sekaligus terus. And then tutup balik. Kita spin. Kita tutup dulu behave dulu Ketam-ketam. Ada ketiga. Lagi 3. One K. Okay, Benetton. Choose one dress, Benetton. Kenapa pasang balik? Nanti gelap bilik ni. Tak nampak viewers ada berapa tu?
Now you have a question, what is the epsilon? Epsilon SU is a uniform strain at the ultimate stress. So basically, this strain
Nanti tiba-tiba pop
is
terpadam.
epsilon SU. From that point, you have a necking behavior happen. Your surface area changes. So you can see that normal ductility is
Hi,
around
Mr.
0.05,
Dragon.
which is pretty high ductility.
Tiba-tiba aku hilang.
Low ductility
Nanti
is
tak ada
0.05.
current kan. Dia
When you
blackout.
talk about the concrete failure, we talk about epsilon CO is around 0.003. So you can see that epsilon SU is much higher.
Bagi
That's why we
viewers.
don't consider it. When concrete reaches this value,
Macam
you
tu.
left and now your structure is almost done. It's almost
Kita borak-borak dulu.
okay. Yeah. So in AS 3600 also give us some table shown here. This is a table 3.2.1. This is a summary about what type of the different reinforced steel we have in Australia we can use. So you can see that your characteristic yield strength or yield stress, you can use either of them, can change from 250 to 650. So 650 is recently added stainless steel bar. Usually we have a traditional element of 500, But now we can also using the stainless steel bar
Tapi
650.
macam nak
Why
buat,
stainless steel? It has
tengah
a very
fikir.
strong resistance of the corrosion.
I mean buat
And still
macam ni
what's the
tapi buat
trouble of
dalam,
using this?
buat
Of course,
private.
price.
Buat
It's
macam ni
much
tapi private.
expensive than normal steel.
Tak ada lebih.
And you can also have a different quality. Okay, and then this is your value of the uniform strength if you want to use. So this is summarized in the paper in AS 36.
You buat join.
Okay. And
Ya, malam bila
here
time?
this arm is
I tanya. Tak ada orang pun nak join.
and
Macam
most of cases you imagine that the formed shape is used. Rounded one
Itu
is
nama orang
only
tak?
specifically used for when you design the stroke, shear strain, you can use it. But even shear stroke, you are
Dia macam mana?
okay. But
Sawer je berapa yang I minta.
stroke and what's the stroke?
Waktu nanti I bagi number phone.
You design the shear of the beam. Okay. So here just you need to little bit familiar about this. What's the meaning of this deform harus or uncensored, and you may know that most of cases we considering deformed and this is the most of general case.
Siapa kata jual kedai main?
People know that average steel reinforcement is deformed.
Siapa
Okay.
kata? Tak kata.
So here this is some table. Just we may see in the design chart, design. I may give this kind of table, then you can just know that what's the meaning of it. So N10 means that it's a normal quality. Everything is D, so that's why I didn't write it.
Ada
So
pun sah.
that everything is deformed.
Tak, I ingat nak buat macam macam ni tapi
so this is 10 millimeter.
tak ada apa macam biasa
5
je.
millimeter steel bar.
Tak ada apa
We
pun.
may using the line up to the 40 millimeter of the steel bar. Okay. Then this is the area. What's the nominal area we calculated?
Hard ideas.
So,
Thank you
if you
more.
actually calculate this base like pi
More
r
dark.
square using the
Respect.
diameter, you may have these values calculated area, but
Tinggu
we're
lah.
not using in the designing is not a really accurate process in terms of the figure and numbers. We actually assume lots of things, so we don't need a very accurate value like 243.32. Doesn't mean it, right? So we are using the nominal area quite a lot, much easier to calculate. So nominal area everything is much
Thank you for your germs.
80, 110. So you can using this area when you're designing it, okay? Better than using the more detailed calculation, which is not that useful in your design process actually.
Kejap lah korang.
Okay. So
Boleh buka semua. Kalau dia bagi 3K terus, I buka semua. Macam mana makan? Apa tu?
we'll go to this slide again. So,
Lisa.
for example,
Hi, keep a toast
confidence
clean.
there.
Thank you, Benetton.
Why we adding reinforcement? Because we want to carry the tensile stress and
Major.
tensile forces. Concrete cannot resist it, so steel will resist tensile forces. And how? We can see it here. So this is a conceptual schematic process. What's the meaning of the reinforced concrete? What's the role of the steel strain? Okay, how we can actually resist the tensile forces in this particular concrete beam. So let's assume that the prismatic bar, which is at the length of L, maybe meter, and then this is a simply supported beam. So very simple cases. So I believe that everyone here is just analyze this simple beam so easily.
Tadi
Okay.
makan pukul berapa?
Then we just apply the very simple 1-point
Pukul
logic.
9
I don't make
setengah.
anything difficult
Tapi
because it's just I want to try to give you some conceptual meaning why we
pukul
are using
9 tapi
reinforced conflict. Then let's assume that we
tak habis
keep
pun.
encouraging
Kami
this force
je.
P until this
Minum
conflict
dulu.
part fails. Here, let's assume that we don't have any reinforcement. Just start that we have a no reinforcement and this is just a conflict thing. Okay? Then you have to think about that what's the resultant stress and moment, and this is a bending moment diagram, and which is one of the easiest bending moment diagram we learn.
Sebab dia makan Maggi je. Makan Maggi je wak.
Right? So you know that the
Ada duit.
over 2, and then if you have an x,
I order food tak tak apa.
then your
Haja je.
moment will be P over 2 times x, right? So you have this triangular shape. Where is the highest moment occur? The center, where your P is applied. So then what's the maximum moment in this entire beam? Would it be PR over 4?
Janji
Where
ada.
x is
Betul?
L over 2,
Setuju?
right?
Sokong?
So this is your maximum moment. Then why do you need a maximum moment? You may understand that cramp or maximum stress occurs under this cross-section because we have a highest moment. Of course, you have this moment and different cross-section, you have a different moment. But why we are interested in this middle? Because we know that from the bending moment diagram, we already know that
Kalau I buat pun lah dia reti.
cross-section would be critical point. Okay, it will break first. Okay.
Ada tapi
So we focus
itulah
on
you tak nak jumpa.
now let's give us some
I
idea.
pada
What's the size
masalahnya.
of the beam? Let's say it has
Makan
a
pun dia
width
makin
of
naik.
beam and height is
Yeah.
okay. So we eliminated this shape of the beam to analyze it, and then now let's just look at this cross section. So this is a D. Okay, let's say this is AA.
Habis bulat-bulat punya nampak apa tau.
This is your A section. Okay, we just put it and we want to look at the internal forces and stress distribution.
Awak punya barang tak best.
Remember,
Saya punya barang best.
so if it has a curved
Saya
shape,
punya
then you
bunga.
can intuitively know that the upper part would be in compression, and then lower part is tension. Oh, sorry, the arrow should be here. So lower part is
Kering tak
tension.
aja.
And then
Mari
this is
sini.
a rectangular
Try barang
shape,
saya.
so without reinforcement, you can easily understand your neutral axis would be middle of it, right? Okay, so your neutral axis is then this is a rectangular shape, so without reinforcement, you
Confirm
can
awak
easily understand your
awak
neutral
kata.
axis would be
Ni dah campur ke ni?
right? Okay, so your neutral axis
All
is
green ke ni? Hong Kong.
E over 2, right?
Walaupun
From there,
I dah
you have a
campur.
compression
Yang
upper
atas.
side and tension in lower side. Then now we bring this Timoshenko beam theory. You may remember sigma equal my over I, and y is from where? This is the y from the neutral distance. The distance from neutral distance to the certain height is a y.
Tak green, agak green.
Calculate the stress in that particular position sigma
Tapi
equal
tak.
y over
tak
I.
okay.
I is what is the second moment.
Nanti orang tanya macam tu. Sebab apa?
It's a moment inertia or second moment of your is a function of your shape, right? Then
Barang saya
now
best.
we have to really think
Tengok
about
kejap.
where do we have a maximum tensile force occur, tensile stress occur in this particular section?
Terlalu patuh ya.
Here.
Betul.
The bottom surface experience the highest tensile stress, right? Because your stress distribution is like triangular shape.
Terima kasih.
The tensile stress continuously increases linearly, and here is the maximum tensile stress.
Nanti nak rasa.
Then where does the failure occur first? We already know that failure occurs here in the middle section, and from the middle section, what part is start to break? From the bottom. Why? It has a highest tensile stress.
Bless you.
Then you can imagine that
Which
when it
is
starts
tu
to
apa?
fail, this tensile stress reach the
Is tu apa?
tensile strength of concrete, then that's it.
Hi Martin.
It's experience the highest tensile stress. Why? Because your stress distribution is like triangular shape. The tensile stress continuously increases linearly, and
Lol.
here is the maximum tensile stress. Then where does the failure occur first? We already know that failure occurs here in the middle section.
Baju apa
And
ni?
from the middle section, what
Nama
part
dah
start
susah.
to break from the bottom?
Jangan.
Why?
Jangan
Because
nampak
of
sangat.
high tensile stress. Then you can imagine that when it start to fail, this tensile stress reach the tensile strength of concrete, then that's the time of the failure, right? So we calculate the maximum tensile
Macam tak
stress
rasa you lah
cross
tak
section
payah lah.
should be
Shy.
or 4i times t over 2, right? So I don't need to explain
Saya
all these
kasih sebut
details,
pinjam.
right? I is t over 2,
Kiwak
and
lah.
mx is already calculated p over 4 here, and I value is 12.
Maksudnya
It
tukar
is-
baju
it
apa
is
ya? Tukar
pretty clearly
dress.
over 12.
Morning you.
Then,
Morning. Okay, tak morning lah.
so
Morning.
this is a case without any reinforcement.
Baju
See that?
Okay,
Your
ini
tensile stress
siapa?
would be
Adakah Abang
much more than
Keper?
compression strength. So we don't worry about
Nama
this
dah
compression
tukar-tukar.
part. Anyway, it
Siapa
can do this
Keper?
much better
Abang
than the
Keper
tensile
ke?
Your failure occurs in tensile part, tensile region, right? And when does the tensile when your failure start to occur here? When your this maximum tensile stress reach the
Dia try jadi model
tensile
pelakon
strength
influencer
of
ke tak
the
nak?
concrete, then your crack happen. This is a
Akan
tensile
nak
region.
jadi
Crack
famous.
happen. This is a bridger, and crack is propagate all the way
Wah,
through the your
ini,
concrete almost. Okay, up to the here maybe, and then
Ini
break.
nakal.
Right?
Kan
So
buruk
this
nama.
is your fate of the concrete beam without reinforcement. Then you can imagine that this is a much lower value, so it cannot actually resist that much of the force. We want to actually using this FC value fully, because this concrete beam has a
Ni
pretty
boleh flip
nice high
warna putih
compression
ni tak
strength.
boleh.
You want to fully utilize it, but if you don't have any reinforcement and just using the concrete, you can never reach this FC value. Just you fail
I
from
pukul
this
1 AM.
bottom and then just
Okay,
crack.
korang.
That's it. Okay. That's why we provide. So this is a sort of failure. I already took that. Once you have a crack, this is a breakthrough. Every crack just pass through all the way. Then you have two pieces of the beam. That's it. Then now let's think about that. Then what happens if you apply the reinforcement in
Hari ni
this
sebab kelas
particular
nak
region
jadi DM.
where we are not
Bila
putting
masa
the
ya,
reinforcement in the
I ada
middle
kelas,
or compression. We
I
put
tak
it
pernah
this
pulang.
one where the tension region. So you can see that your reinforcement is near the bottom, right? Because we know that this will give a flexural behavior, and we know
Capek
that where
ya,
the tensile
iya
forces
capek.
occur. So
Capek
we
dikit
place
dong.
the reinforcement in that
Sikit
particular
aja.
region. So we have a this
Siapa-siapa ready pukul 1 lah. Korang memang nak kena.
reinforcement. And if you look at this section, you can see that just the dot point. This is your cross section because your longitudinal
Daripada depan
reinforcement.
hostess camp. Tah! Berani dia menjual kat sini.
Right? Then this one, when the crack occurs, this
Mesti
one we
ada
cannot
lompat
avoid.
kan?
Sigma T-max is very easily reaching.
Mana ada tu? Badan I clean.
First crack occurs actually very
Ada lama
fast.
tak?
Then we cannot
Thank you,
avoid it. But
Benetton.
once we have a crack, this reinforcement there start to resist. Okay? So all tensile forces
sekarang
now
behave
just
jadi budak baik.
transfer by the
Malam
reinforcement.
keluar
So
kawan
this one is
je.
holding the tensile part.
Adik.
So reinforcement
Mati pun
carries
tak.
internal tensile forces through the bonding behavior.
500 tukar baju apa tu?
And
Dress.
now you don't have this crack.
Baik
You have a
sangat
multiple
kan?
crack in different direction. And then now this beam start to showing some kind of a ductile behavior, not the breakthrough. Okay?
Baik ada
So
makna.
this is how the reinforcement
Mana
works.
ada.
Okay? Why this
I
reinforcement
know,
we
baik.
are actually holding the tensor. This is a concept. Without that, we cannot make the beam. We can
Piu.
make a
Hi,
concrete
Mr. Black.
column. If you go to the Roman or very old Asian one, you can maybe see that every column, every component is only compression one. Doesn't resist the tensor. You cannot have a beam or slab.
I pun mengaku I baik.
It's pretty good.
Maksudnya
They,
apa?
at least this Asian
Kisah
people
live.
also know about this issue,
Bibi
so
tolong.
they make the arch
Emoji tak
or
payah.
compression component. Okay. Okay. So you can read this bullet point. This is explanation why we need a reinforcement reverb. Okay. So now let's look at the section. Then this is a cross section, very simple cross section of the beam of the reinforced concrete. Then this is all your the concrete beam
Still not
cross
going down
section,
yet.
and then you can see that there
Apa?
is a reinforced rebar passing
Apa you
through
punya
each
ni? You
longitudinal
punya
direction.
telung.
This is actually holding your tensile force
Ke
if
viewers.
you have a tension in lower region, bottom region. And you may see that this kind of a strop. Strop is the shear reinforcement. We may
Viewers.
see why we need this shear reinforcement. This is also important. And you can see that later when you design the shear reinforcement.
Bukan dong.
And but you can
Sebab
in normal concrete, you
orang-orang
already
Bigo
see that this
suka
shear
orang
strop
mengarut
which
tau.
is vertically located with a certain interval.
Sebab I
it's
pun dah
like
macam
this. So you have this beam.
biasa. Macam tu tak boleh
Your
beza.
longitudinal rebar
Dia nak mengarut ke
pass through the whole like straight
pura apa ni?
this direction.
No worries. Okay.
Okay.
Oh tak
And
nak
then
kena
your
hijack.
strop
Ya
will
tu.
go to the like this one.
Ada setengah yang normal
This
tau.
first direction, and
Tapi
we have a
mostlynya
certain
buat mengarut.
space of the strop. Okay. This is how
Dia orang
the
mengarut tak apa.
beam
Dengan design yang
reinforcement
mengarut.
looks like. And here you need
Maksudnya
to
kadang-kadang pelayan.
some terminology. So we already see the strop. So this is your shear reinforcement.
Tapi yang kamu cakap
And
tadi benar.
we need to know about a cover.
Oh, tadi
means
comel sekarang dah
like a
seksi.
clear concrete cover to protect the
Kita ada dua
surface of
side. You nak yang mana
reinforcement
satu?
from the
Comel
corrosion.
boleh.
Okay, so when it doesn't cover that, this is called cover
Bola
depth.
kecil.
And so there the axis is from the bottom to the centroid of the steel rebar. This is not extremely
Lisa
important in this
jam.
particular design, but
So
we
siapa yang
take
tukang
note of
garut?
terminology and
Yang
cover.
penting bukan I.
But here, on the
Yang
right
penting
side, we have to
bukan
focus on
I.
in the right side, and now we have
Comel
to
side lah. Boleh, boleh, boleh.
Is it not
Kita tukar comel side lah.
right? You have to understand about. We strategically place the reinforcement certain
Fikir.
area, especially what area is it? Now you understand the tensor region. We need to find out where this structure has the tensor regions, and that part has to be reinforced.
Amirul ada.
Okay, compression is fine.
Siapa Amirul?
Just the compression. So with the beam, you
Kalau
have
kita
these two
tukar
beam.
comel side lah
The
eh.
top one is the
Check.
positive moment. So here in entire class, for this is important. We have sign convention because you know that sign convention can be different. So not like to put the plus compression or minus compression, which all depends on your decision. But in this class, to make it consistent, we make the whole this direction of the moment, which make the concave shape of the beam. This is a positive moment. Okay, we say this is a plus moment. Okay, then in this positive moment, you can see that tensor region is the bottom. So your reinforcement has to be located in the bottom region, right? You see that? And of course, some place maybe you have opposite behavior, so then you have a convex shape. So in this cases, we call it. I'm confused about concave and convex. So then maybe convex and concave is a perfect behavior. Just tell it to you. Is it this concave or convex? It's convex. So everybody's convex.
Okay, ni comel saya.
Okay. So if you have this shape, this is a positive moment, okay? And then if you have a deflection upper side like this way, this is a negative moment. Okay, our research later somebody's convex. And this is a negative moment. Unconfusing, okay? And then here you can see that where is the tension part? Up place, right? So you can see
Dah
that
tak
your
best.
reinforcement
Memang lah.
is located in the
Kata nak comel.
convex.
Nisa macam dah kurus.
And let's just look at
Sebab
the simple
I
practice here. We
dah
have a
3
continuous
minggu
beam
sakit
with a
gigi.
span.
Lepas tu
And then
sekarang
let's
baru
look at
okey.
certain this single two type of the point body. And you have the
Thank you
definition
Kang
how we take care,
Sayo.
right? So
Tak
you
nak
know,
baju
so
ni, tak nak baju ni.
structure analysis,
Pergi
and
sampai.
if you have a good intuition how it becomes shape
Berat
like
je.
this one,
Apa
right?
yang berat?
Okay, then you can now
Apa yang
understand
berat?
what is the tension region.
Banyak benda yang berat ni.
Here in the middle part of the section, this is the
Wow,
tension region,
lawanya.
right? And here this is the tension region. And in the near of this,
Lawa
on this
rambut.
map, you
Thank
can see that
you.
this
3 minggu yang lama sak. Ya.
So are you sure? Clear?
Tu sampai kurus tu.
If you draw the deformed shape, you can imagine that where is the tensor with the compress. Okay? So
Jangan
we can see
rindu
that this
nanti
straight
berat.
tensor
Ya,
with then where do you place
Hah?
your reinforcement? Longitudinal
Hah?
reinforcement. Should be
Hah?
bottom in the midsection and top for your midspec area.
So
Okay?
left kau berapa step?
Got it?
Dah
Of course,
tahu
there
lah.
are so many different
Kadang
rules that carry out
10,
what's this length or how
kadang
many
11.
we are not talking about
Kadang awal tu lambat. Macam tu lah.
simply understand how we can
Tapi
spread
kalau
this
lambat sangat
tree,
tak lah.
so
Kedua tak.
and this is like something cantilever shape.
Jangan
And
dekat
you
sangat.
provide a lot
Muka
here.
tu cium kat.
Then you can see that this kind of
Yang seminggu lebih pun dah perit nak tahan. Ya. Yang sampai pergi klinik.
This one and this one.
Tak cantik baju ni. Tak apa.
So,
Bagi I
of
cantik.
course, this is a very
Ni
important
macam
thing.
dress berdiri jap.
Inclined reinforcement anymore, but
Kenapa ah?
this cantilever, this part, this is
I rasa dress ni biasa je.
and this is the tension, so we place
Cabut gigi ke tak? Nak cabut ni lah. Mahal sangat lah. 1,500 Dia kena operate. Yang penting I dah kurus.
So let's a little bit go faster. So here I found that this is a convex shape, okay, and this is a negative moment, okay, and this is a concave, and this is positive. Of course, you don't need to confuse our convex and concave. It's not important. Just the important thing is what's the positive moment, how the shape looks like, what's the negative moment. Okay? We will keep using this sign convention consistently. Okay. So let's a little bit quickly go through what's the load factors. So here now you have different components. All structure is actually connected with different components of the structural component. Slab or column, everything is connected to each other. So if you actually apply such an external load, this load has to load each component finally to go to the foundation on the ground. So we may have some idea how this load flow, and it will give us some idea. And the stress is the point we have to consider in such a some design applied and then it gets to work like particular scenario.
Tak payah cabut.
To do
Sebab dia tumbuh
that,
cantik.
we are not. This is
Tapinya
later.
nak tunggu dia tumbuh tu. Selama 10 minit you end ke saya.
These beams are connected for different columns, and then if you apply some load on the slab, and then right, see the joist. This is a bit of really small beam, and then there is another big beam. Maybe have a name further, and let's look. Right, vertical two direct faces. You can see that every load applied here.
Tinggi bisa berapa? Cuba teka. Dia pun seminggu tak makan apa cabut. You operate ke? Over lah baby. 155 betul.
This one way direction is there is a particular cost. So we there the if you like
156.
if this is an L1, if L2 is greater than 2, so we have a bunch of room for one side, then we usually assume that this is a one-way slab. Okay? Then
Okay.
here now we can really think about the load.
Berapa lama nak elok? Minggu?
The joist part. So let's focus on the joist part, which means that this three different beam.
Minggu tak boleh makan ke?
Particular joist has the distribution of the load to the uniformly distributed load. You can imagine the wire. All this slab part transfer the load to the
Mestilah sakit.
small beam.
Kan?
So we imagine that either experience
Makan bubur je lah.
or
Wisdom ke? Yes.
right? This is you can explain.
Masalahnya tak cabut pun dah kena makan bubur. 1 minggu tak boleh makan bubur.
Will be experience uniformly distributed load. And then let's go to the beam. All the beam is 1, 2, and the big beam which support the 3.
Sekarang baru elok.
Right? Then you can also see that by looking at this particular structure, you can assume that this one maybe experience
Sekarang baru elok.
3 points from the where.
Tu macam saya tengah fikir. Nak cabut juga ke tak payah? Sebab dah elok.
So it doesn't have a
Dah boleh makan.
And then this one is also hooked by here. So you have a two-point
Dia
load
tidak ada
distribution.
rasa sakit tu,
And then, of
tapi
course, there may be
tak
some
teruk lah.
distributed
Berapa
load
58?
weight. We can self weight, right? But here we don't consider the self weight at this moment. Just looking at this load passage, you can, by looking at the structure and their shape, may have a different stress resultants, which will be considered. That's what I want to go over. Okay? And
Nanti kalau jadi lagi laki-laki, you go.
so if you have a column, you can see that this is column, and typically here,
Diet
like this point load.
Mana diet? Nampak I kurus ke?
So this is a
Tak payah
simple
biasa
case.
yang sahabat sebab tunggu
Each
tak cantik
component,
akan sakit.
we might consider different load combination. Okay. Joist, maybe we need to consider self-weight evenly distributed load.
Faham?
For the big order, maybe we need to consider point load, and column we may consider actual load. Right. So this is
Tak
how
kurus makin bersih.
and this is about the one
Serius
slab,
ah?
two slab, and one slab. Then two slab, the load
Amin
passes
kurus tau.
points over to two different direction. One slab, just the one direction. And how do we decide this is a two slab or one slab? Typically, we are using the ratio of the long side to the short side. And long side to the short side is greater 2, then we simply assume that this is two slab, which is more easily designed.
Ingat
And
telefon
if
lain.
you have this kind of cases, and it's a two slab. Okay? And this is another internal forces flow inside of the rainbow.
Hai Raza.
So you may read this one quickly, then you can understand that if you got this type of the vertical load, the vertical load applied to this slab on the top, and this slab and beam, they transfer the load to the column. Okay, in actual load, and this one is actually transferred through the moment and shear force, like that, and then it will finally flow through it and then spread to the spread through it. Okay. And but same frame, maybe you have another load combination. You may have horizontal force like wind force or space or something. If you have a horizontal force, then you can see that your column now transfer the load as a shear, not the texture, and then your beam is actually now express the actual force, not a momentum or thing. So
Ada.
same frame, same design, depending on
Tapi
the
kat
one
luar,
load is
dalam
applied,
plastik.
you need to consider different scenario. That's why I'm talking about that you may need to
Tu
consider
sikit yang kena buang tau.
different load combination.
Nama
And
I.
you come up with a worst case scenario.
Dia
This is
lupa
worst case
buat
to
baju.
apply this particular member. Then
Ingat dia
you
buang tapi
design
tak ada
to
tak.
list
Dah
these
suruh.
worst cases. Then it
Sampai dah
helps
jumpa.
to design for your different member. Okay. So this is summary. So I think I should skip it. Okay, let's do that.
Bab dia 5 bulan 8. Mana dia yang letak kat luar? Tak minta air.
Design process.
Dia kan ambil air.
Still, we haven't gone to the very details
Lepas tu
about
dia
how to
jumpa,
design
dia letak
this
dalam
and
plastik,
such a
dia
thing.
letak kat luar.
Still, we are introduction part, so let's go through it. So there are two different things: structural design and analysis. And then analysis is what you have done in the previous prerequisite. Solely the structural analysis reading. So let's go to the next step. So we will
Dia kata
this section very quickly.
dia nak bakar.
What type of things we need to consider?
Tapi
Then we go through the
dia tak bakar pun. Dia sorok je. Tapi sorok pun adalah tempat yang tak tersorok pun. Oh, I pun birthday bulan ni 28. Oh ya ke? Happy birthday. Tak tahu kan Nisa masuk kat polis. Tak ah. Dia tahu. Baju-baju tu I pakai pergi parti.
Oh, nah.
Dia cakap, buat apa pergi parti tu? Seronok sekejap je. Lepas tu balik rasa kosong juga kan. Awalnya wish biar biar awal, jangan lambat.
The result of the structural analysis. The structural
Tapi I tekad bulan ni I nak tekan sikit I punya tas ni. Maksudnya apa? Maksudnya I nak rajin buat live bulan ni. Dan hari-hari. Okay. Tengok macam mana. Happy birthday. Happy birthday Zah. Thank you Razak. Sekejap ni korang. Tengah zomba. Selepas birthday tu pergi mana? I celebrate kat rumah je. Dengan family I. Tu pun I tak tahu. Kawan-kawan I yang buat surprise. Yogi tak galak event tadi. I tak tahu pada event tu. I ni Eunice tak buka group. So I tak tahu pun. Kalau I tahu, maybe I pergi kot. Banyaknya koput you tak habis tadi. I muka susu. Sebab gigi I still sakit. Tapi at least boleh mengunyah lah. Ben. Sakit gigi. Maknanya kena share. Habis dah nak habis. So tas macam mana? So far okay. Awal-awal lagi. Kita tak tahu lagi macam mana pergi ni. Baru 10k. Not bad. Baru 2 hari I live. Hello Dolphin. Dolphin pula. Alhamdulillah habis. Okay. Hari ni betul habis. Hi AF. Berdiri jap nampak kurus pula. Ya, I memang dah kurus sekarang. Memang gila views. Tak tahu lah dia orang suka sangat kot dengar I sembang. Borak kecil. Okay. Awak janda kan? Terkejut kita. Kahwin pun tak lagi, boyfriend pun tak ada. Tiba pula janda. Baru dapat hot pakai spek. You dulu ya. Okay, Benetton. Thank you, Benetton. Semoga awak dimurahkan rezeki yang dipanjangkan umur. Esok masuk lagi, Benetton. Macam Mia Khalifa. Siapa? Cari ya boyfriend, malas. Live sampai pukul 1. Siap lah Mia Khalifa. Jauh siap. Masih Mia Khalifa. Sudahlah. Tak nak. Nampak sangat semua yang jenis. Semua tahu pula. Macam mana korang boleh tahu? Macam mana korang boleh kena kahwin lambat rugi? Kenapa ya? Tak nak. I nak kahwin lambat-lambat. I nak enjoy dulu. Alam Mia Khalifa bernyanyi tu lah. Tak payahlah. Tak payah nak membongak. So Mia Khalifa tu I tak kenal pun. Tak payahlah nak menipu. Bibir I memang kering tu. Saya pun tak kahwin lagi, dah tua ni rasa tak seronok. Bila abang nak kahwin bang? Sudahlah korang, tak payah nak berlakon. Okey lah korang, kita sambung esok lah. Alright? Thank you korang. Si Mia terus Bigo kat ke? Acah-acah lah korang ni. Tapi tengah tunggu seseorang, faham? Okay korang, bye. Thank you yang mana join, yang bagi gift. Semoga korang dimurahkan rezeki yang dipanjangkan umur. Happy birthday Zah, thank you. Okay lah, kita 360 betul terus end. Okay korang, bye. Good night. Sambung esok. Bye-bye.